A telescope is an instrument for magnifying distant objects, such as stars and planets. Like a microscope, a telescope consists of an objective and an eyepiece, or ocular. When the objective is a lens, as in this case, the telescope is referred to as a refracting telescope since lenses utilize the refraction of light. There is another type of telescope that uses a mirror for the objective. A telescope that uses a mirror for the objective is called a reflecting telescope. Here we discuss a refracting telescope in the form of the two-lens system shown here. Usually the object being viewed is far away, so the light rays entering the telescope are nearly parallel, and the first image is formed just beyond the focal point FO of the objective, as shown here. The first image is real and inverted. Unlike the first image in the compound microscope, however, this image is smaller than the object. If the telescope is constructed so that the first image lies just inside the focal point FE of the eyepiece acts like a magnifying glass. It forms a final image that is greatly enlarged, virtual, and located near infinity. This final image can then be viewed with a fully relaxed eye. The angular magnification m of a telescope, like that of a magnifying glass or a microscope, is the angular size theta prime subtended by the final image of the telescope divided by the reference angular size theta of the object. For an astronomical object, such as a planet, it is convenient to use as a reference the angular size of the object seen in the sky with the unaided eye. Since the object is far away, the angular size seen by the unaided eye is nearly the same as the angle theta subtended at the objective of the telescope as seen here. Moreover, theta is also the angle subtended by the first image, so theta is approximately equal to negative hi divided by fo, where hi is the height of the first image and fo is the focal length of the objective. A minus sign has been inserted into this equation because the first image is inverted relative to the object and the image height hi is a negative number. The insertion of the minus sign ensures that the term negative hi divided by fo, and hence theta, is a positive quantity. The expression for theta prime is obtained by noting that the first image is located very near the focal point fe of the eyepiece, which has a focal length fe. Therefore, theta prime is approximately equal to hi divided by fe. Substituting these values for the angles and canceling the image heights hi from the numerator and the denominator, the angular magnification m is approximately negative fo divided by fe. The angular magnification is therefore determined by the ratio of the focal length of the objective to the focal length of the eyepiece. For larger angular magnifications, the objective should have a long focal length and the eyepiece a short one.